this is Unit 9, Lesson 3, and I've already posted within my teacher homepage an initial video explaining how we're able to achieve the ordered pairs that correspond to the specific 30, 60, 90, and so on. So in increments of 30 degrees and in increments of 45 degrees. How are we able to achieve those ordered pairs and how they relate to one another? Now, another reminder is that tangent is the same as sine over cosine. And so when we look at the ordered pairs, it's always cosine before sine. So cosine's first, sine second for every ordered pair on this unit circle. So let's go through and let's do some very easy ones. I was going to achieve the tangent knowing that it's sine divided by cosine. Cosine's always first, sine second. So what is 0 divided by 1? Well, 0 divided by 1 is 0. So I'm just going to circle. This is a tangent of 0. Now here's another very easy one. If I take sine divided by cosine, they're the exact same value. When you take the same value and divide it by itself, you get an answer of 1. 1 divided by 0, we can never have 0 in the denominator. That would be undefined. We'd have a vertical asymptote at 90 degrees, also known as 1 pi over 2. Now over here at 135 degrees, also known as 3 pi over 4, again I'm going to take the sine and divide it by the cosine. So I have the same values, so I know that I'm going to have an answer of 1, but now I have to think about what sign should be attached to the 1. So radical 2 over 2 divided by a negative radical 2 over 2, because they're different signs, my final answer will be negative 1. At 180 degrees, sine divided by cosine, 0 divided by negative 1 is in fact 0. Let's jump down here to 225, also known as 5 pi over 4. We have the same value and they have the same signs. So sine divided by cosine is a positive 1. At 270 degrees, negative 1 divided by 0 is undefined. Remember, undefined will leave us with a vertical asymptote. Let's jump over here, and we have sine divided by cosine. I know I have an answer of 1, but attached in front will be a negative sign because a negative divided by a positive is in fact a negative. You may be wondering, why didn't I go through and figure out the tangents at this point of these other points? And the reason is because I believe this will be enough to allow me to graph number 1, which is y equals. All right, so I've gone ahead and taken what I just went over with you on this unit circle, and you can see in red I've done the tangent of a few specific points that are very easily to calculate, and I've put that into this basic unit circle. So this would be, if we want to say degrees, this is 0 degrees, 45, 90, 135, 0, 225, back to 270, 315, and 360. So I'm going to use this as I go ahead. Now what's different about tangents versus sine and cosine is, in order for us to figure out the period length, also known as the period, when we worked with sine and cosine, we'd take 2 pi and divide it by the value in front of the x. Now with tangents, we'll take pi and divide it by the value in front of the x, which is a hidden 1. Pi divided by 1 is simply pi. So one cycle is a length of pi for tangent functions. Now to figure out the x scale, it still has 4 steps to it. Remember, for sine, it was a hill and then a valley. And for a basic cosine, it was hill, valley, hill. That was 4 cycles. Like if you're wondering how I'm counting, again, for sine, it is starts here and that's 1, 2, 3, 4. That's a basic sine. For cosine, it is 1, 2, 3, 4. So I'm still going to do 4 steps. So to figure out the x scale, which is the distance on the horizontal axis, I'm going to take the period length and divide it by 4. All right, let's get started here. So I'm going to take this picture. I'm going to put it here. Let me adjust this so let's get started here. So I have the unit circle and I put the appropriate measurements in terms of radian measurements. So pi over 4 is equivalent to 45 degrees and pi over 2 is equivalent to 90 here. You may be wondering, why didn't you put degrees instead of radian measurements? Because my period and my x scale are in terms of radian measurements. So 1 period length. So 1 cycle is a length of pi. And each one of these movements, so this length, 1 step, is a distance of pi over 4. So when I go over 1 spot along the horizontal axis, let's figure out now the output for pi over 4. So here's pi over 4, also known as 45 degrees. The output is 1 for a tangent function. So I go over pi over 4, the output is going to be 1. Now, if I add up a pi over 4, which is 45, 45 and 45 is 90. 45 and 45 is 90. So step 2 goes undefined. Undefined means a vertical asymptote. Our function is never going to cross that line. Okay? Now, let me move this over once again. Okay, now we're going to go, so I've done 0, I've done 1, and I've done undefined. Now I'm going to go to the left. So it's like I'm going a negative pi over 4, or I'm dropping down 45 degrees. Remember, when I go to the left, it's going to be a negative. So this is a negative pi over 4, and the output is negative 1. So I'm going over and down negative 1. When I go 2 steps to the left, I get an undefined. So a negative pi over 2, or a negative 90 degrees, gives me a result that is undefined. And as you recall, with asymptotes, it gets closer and closer to the asymptote. So as it moves to the right, it's getting closer and closer to this asymptote at x equals pi over 2. And as it moves to the left, it's getting closer and closer to this asymptote as well of x equals negative pi over 2. That's 1 cycle. So it's still 4. 1, 2, 3, 4. So it's broken up. And the length of each one of these is pi over 4. And this entire distance is a distance of pi. And that makes sense. Remember, half of a circle is 1 pi. 4 pi over 4 is 1 pi. So half of a circle is 1 pi. And we just did half of a circle. We just went from here to here. It's half of a circle. And this will now just continue. So I'm going to do the exact same thing over again. I'm just copying like I did the pattern. Up and gets closer and back down. And I'll do the same thing over here. Okay, now let's count and let's see, how far did I actually go to the right? Well, each one of these represents pi over 4. So I have 1, 2, 3, 4, 5, 6. So I have 6 groups of pi over 4. So 6 groups of pi over 4. And that would be 6 pi over 4. And that's not wrong, but when I reduce it, they're both even. We get 3 pi over 2. Now to the left, I have 1, 2, 3, 4, 5, 6. The same thing. 6 pi over 4. And since it's going to the left, it'd be a negative 3 pi over 2. So a positive 3 pi over 2 to the right and a negative 3 pi over 2 to the left. All right, I'm going to start by looking at this function. I have y equals tangent of 2x, and let's identify the period length. So I'm going to take pi and divide it by whatever value is in front of the x. This time it is a 2. So pi over 2, 1 length. So 1 length, 1 cycle is the distance of pi over 2. Now let's figure out, there's still 4 steps. 1, 2, 3, 4. So I'm going to take this value and divide it by 4. Now remember, when you divide by 4, we turn division into multiplying. And we take the second fraction, take the reciprocal of it. So I have 1 pi over 8. 1 pi over 8, also known as pi over 8. We get the exact same shape. So we start here, up 1, down 1. And I'm going to, so that's right here, right there. Still the exact same shape as our previous graph. And you may be thinking, well, what is the difference from number 1 to number 2? Well, let's talk about that as soon as I finish graphing this. The difference from number 1 to number 2 is the length of 1 cycle of this function This length is a length of pi over 2. Now, I'm a visual learner. That means from 0 to pi over 2, this is the length. Let me move this down so you guys can see. This length from 0, so it's a fourth of a unit circle. In a fourth of a unit circle, we make one cycle of a tangent function. On this graph, it would be a length of pi, so it would be a half of a unit circle it takes to make one cycle of this function. So this particular cycle of the function y equals tangent of 2x can be done in half the distance along the horizontal axis. Let's look at number 3. Okay, so number 3, if we think back to how we graph sine and cosine functions, whenever the value out front, forget about it being positive or negative. When the value out front is greater than 1, we're going to stretch the function. It's going to rise and it's going to fall faster. When it's negative, it's going to flip the direction. So like for sine, we would have generally have done a hill and then a valley, but if there was a negative in front of a sine function, we would just flip the order. The same thing can be said for a tangent. So generally we would go down to the left. When there's a negative, it's going to be down to the right. So how can we go about doing this? Let's first start with what is the length of one cycle. I'm going to take pi, I'm going to divide it by the value in front of the x, which is a 1. So this is the period length. And now each step along the horizontal axis will take that value and divide it by 4. So the scale factor, or the length along the horizontal axis for one step, is going to be pi over 4. The value out front will be multiplied by the output. So I'm going to start at 0. 0 times negative 3 is still 0. I am going to take this value out front, and I'm going to take it times the output. So let's start at 0. At 0, 0, the output is 0 here, it's in red, times negative 3 is 0. Let's go over to pi over 4. So that's one step over is pi over 4. The output is 1. 1 times negative 3 is negative 3. Now let's go over another distance of pi over 4, which now brings us to 90 degrees, and I have an undefined. So negative 3 times undefined is still undefined. Okay, now let's go and reverse it. So as I go to the left, I'm going to reverse directions. I'm going to go a distance of pi over 4, which is 45 degrees, dropping down, taking the output, which is negative 1 times negative 3 is positive 3. And now I'm going to drop down 2 groups of 45 degrees, which is 90 degrees. I get undefined. All right, so now we have comes in and down, comes up and gets closer and closer to both vertical asymptotes. And now we can just take that exact same cycle and just copy it. So I'm going to drop down 3 and up 3. I'm going to drop down 3 and up 3. Sorry, my son is learning how to tie his shoes right now, and he's throwing a fit over it. He wants somebody else to tie his shoes. Okay, so this is what I have. Now let's talk about how long is this. So 1, 2, 3, 4, 5, 6. So I went 6 groups of pi over 4. Each step is pi over 4. And this is 6 pi over 4. It reduces to 3 pi over 2. Now I went 1, 2, 3, 4, 5, 6. So it's exact same thing, but we're going to go a negative 3 pi over 2 to the left. Okay, let's take a look at number 4. All right, let's take a look at number 4. So I'm going to rewrite this as y equals 3 tangent of 1/2 x. Now to figure out the period length, I'm going to take pi, not 2 pi, easily to be confused with graphing sine and cosine functions. I'm going to divide it by the value in front of the x. Now when you divide, I'm going to put this out vertically. So pi over 1 divided by 1/2. I'm going to turn division into multiplying. I take the reciprocal of the second value. So I get 2 pi over 1, which is the same as 2 pi. And like sine and cosine, it still has 4 steps. So I'm going to divide this by 4 equal parts. 2 pi divided by 4 equals 1/2 pi. All right, so the value in front because it is a number larger than 1, it doesn't matter if it's positive or negative, it tells me that we're going to stretch this function. In comparison to the parent function number 1, it's going to be stretched. It means it's going to rise faster and fall faster. Now, it's not negative. Also keep that in mind. So it's not going to be going down to the right. It should be going down to the left. So how do we do this? Let's start here at 0. 0 times 3 is still 0. Now I want to go over to, so I'm going to go 1 here. 1 times 3 is 3. I'm going to go up to 3. And now I'm going to go over undefined, so it's undefined here. And negative 1 times 3 is negative 3, and also undefined. So it's coming through and up and down. Now this length of one cycle is a distance of 2 pi. This is a distance of 2 pi, and each one of these lengths on the horizontal axis is a distance, so each step is a distance of 1 pi over 2. All right, so let's continue to make this up 3, down 3. And don't forget about the vertical asymptotes on the far left and on the far right. 1, 2, 3, 4, 5, 6. So 6 groups of 1 pi over 2, because I know that each length here is 1 pi over 2. So I have 6 pi over 2, which reduces to 3 pi. So 3 pi to the right and okay, so let's take a look at number 5. Let's start with the period length. I'm going to take pi and divide it by the value in front of x, which is 3 pi. The pi's are going to be reduced down to 1, and I end up with 1/3. So that's the length of one cycle. Now let's talk about the x scale. The x scale would be the length on the horizontal axis for each step. I want to take this value and divide it by 4. Remember, when we divide by a value, we're really going to turn division into multiplying, and multiply by the reciprocal of the second number. So I get 1/12. We do have a negative 1 in front, so instead of starting at 0 and going over 1, up 1, this is going to reverse the direction. So I'm going to go over 1, down 1, and again, instead of going over 1, down 1, I'm going to go over 1 and up 1. And so we have this function. I'm going to repeat the cycle and repeat the cycle. Okay, so now let's count. I have 1, 2, 3, 4, 5, 6. So 6 groups of 1 over 12. 6 groups of 1 over 12 would give us 6 over 12, which reduces to 1/2. And then we have 6 groups to the left, so negative 1/2. Let's take a look at number 6. I'm going to rewrite number 6 as y equals 2 tangent of 3/2 x. Let's first identify the period length. So I'm going to take pi and I'm going to divide it by 3/2, which is a value in front of the x. Remember that we're actually going to turn division into multiplying, and we'll multiply by the reciprocal, which is 2/3. So I get 2 pi over 3. 2 pi over 3 is going to be the period length. Now I need to divide this by 4 because there's 4 steps. So here's 1, 2, 3, and 4 for every cycle of a tangent function. So I'm going to take 2 pi over 3, and as remember, when we divide, we're going to multiply by the reciprocal. So I get 2 pi over 12. Well, 2 pi over 12 is going to reduce to 1 pi over 6. All right, so let's get started. I've taken care of this number. That's helping me with deciding what is the period length and the x scale. Now the number in front is going to stretch this function because it's positive. We'll continue with the basic. I start at 0. Instead of going up 1, 1 times 2 is I'm going to go up 2. Instead of going down 1, I'm going to go down 2. All right, so it's going to come up and then down, up and then down to the left, up and then down to the left. All right, we have a distance of 1, 2, 3, 4, 5, 6. So 6 groups of 1 pi over 6. 6 over 6 is 1 pi to the right and negative 1 pi to the left. Let's take a look at 7. All right, let's take a look at number 7. So to start off with number 7, the first thing we need to recognize is there is a vertical shift. So I'm going to shift everything down 1. And so I'm going to start by just making a little line here. We've shifted everything down 1. And now that I've taken care of that, I'm going to cross it out. Let's go back to our period length. I'm going to take pi and divide it by the value in front of the x, which is a 3. So pi over 3 is going to be the period length. And now I'm going to divide this value by 4, which means I'm going to multiply it by 1/4 to get 1 pi over 12. 1 pi over 12. Now, the number in front is a 2. It's positive. So I'm still going to go over and up and over and down. We only change that direction when this is negative. So from this, which is like my new origin, instead of going over and up 1, I'm going to go over and up 2 and over and down 2. All right, so we have, it's going to go up here and down, and I'll do the same on the left and on the right. And I do want to identify those other vertical asymptotes. Okay, so we have 1, 2, 3, 4, 5, 6. So 6 groups of 1 pi over 12. That'd be 6 pi over 12, which reduces to 1 pi over 2 to the right and negative 1 pi over 2 to the left. All right, let's take a look now at number 8. First, I'm going to start by moving everything to the right, or sorry, everything up to. You know what? I'm going to rewrite this right now as y equals negative 1/2 tangent of pi over 2x plus 2. Okay, I'm going to move everything up 2. That's my first thing. I've accounted for that. Now let's identify what is the period length. Okay, so coming back here, to figure out the period length, I'm going to take pi and divide it by the value in front of the x, which is pi over 2. So I'm going to divide this by pi over 2. When I do division with fractions, I'm going to turn division into multiplying. I'm going to take the reciprocal of the second, so I would get 2 pi over pi. Now the pi symbols are going to be reduced down to a 1, or in your mind you may think canceling out, and we have a period length of only 2. Okay, then I'm going to take the x scale. So I'm going to take the x scale, which is taking this value, 2, and I'm going to divide it by 4. When I divide it by 4, it reduces to 1/2. So I've taken care of this, which impacts my period length, and the x scale, I've taken care of the vertical shift. And now there's 2 things here. Since this value, don't worry about it being negative, since 1/2 is between 0 and 1, we're going to take this basic shape and it's going to be compressed or flattened out more. That's how it's going to impact it. Now the negative sign, instead of going down to the left, it's going to be going down to the right. So we would normally start right here, and I normally would go up 1, but this is going to say go down 1/2. Normally I go down 1, but now it's going to say go up 1/2. And I can repeat that to show 3 different cycles here. So there's the 1, coming over, up 1/2, down 1/2, down to the right, down to the right. Okay, 1, 2, 3, 4, 5, 6. 6 groups of 1/2, which gave us 6 over 2. 6 over 2 is going to reduce to 3 to the right and negative 3 to the left. Okay, so I've gone ahead, I plugged in the tangent of x, you can see that here. I've gone ahead and plugged in the x minimums, the y minimums, maximums, the x scale, and the y scale. So that's all can be seen here. When you press enter, for instance, negative 4 pi, you press enter, it turns it right into a decimal. So I've graphed it. And now I'm not going to take time to do all of these since you were provided with an answer key, but I do want to show you how to use a trace feature to evaluate the following trig expressions. And then again, you were asked to round them to the nearest thousands or 3 places past the decimal. So second, trace, and I want to find the answer. I'm typing in pi divided by 4. Don't type in 3.14. We want the actual pi symbol. And now we don't have to round this. It's just an answer of 1. Let's do 3 pi divided by 4. I get an output of -1. Negative 3 pi divided by 4, an output of +1. Now when I do part D, I get pi divided by 2. I get no answer. No answer means it's undefined. Undefined would be those vertical asymptotes. So UND in your answer key is going to be abbreviation for undefined. And we can see the same thing if we do 3 pi over 2. We also get an answer that's undefined, as well as 5 pi over 2. It's also undefined. Let's do one more. Let's go down to option M on your paper. Option M does not show up for me. It may be the same thing for you. Option M is the tangent of pi. Option N does not show up in my paper. It's a tangent of -pi. And option O is tangent of 2 pi. Okay, so we're going to go second, trace, and let's do just the tangent of pi. I get an answer of 0. If I do -pi, I get an answer of 0. And if I do 2 pi, I still get an answer of 0. So yes, I want you to do all of these, and I did provide you with the answer key. I just wanted to demonstrate how to use the trace feature to get those answers.